Hello, dear audience. My name is Emmanuel Bird, and I'm presenting the work Oscar and ActivityNet. An image captioning model can effectively learn a video captioning dataset. This work's motivation comes from seeing that video captioning is very expensive. So we experimented with an approach based on image captioning. We transformed the ActivityNet dense video captioning dataset into image caption pairs, resulting in an image captioning dataset. And we trained current state-of-the-art image captioning techniques, mainly bottom-up attention and Oscar, to predict their captions. We experimented also with different data augmentation techniques to increase the number of reference captions for each image, and we evaluated with 4 of the most common metrics for image captioning. The current dataset transformation is fairly simple. ActivityNet's captions are temporarily annotated and they overlap in some places. In order to solve this overlapping and have uniqueness in both the frames and the captions, we chose to pair each caption with the central frame in their temporal dimension. This resulted in 31,000 training samples and 5,600 validation samples, which come from the 85 and 15 split of the training set of one of the datasets provided by ActivityNet to encourage the participation on the challenge. Features extraction comes from the Anderson et al. Bottom-up attention mechanism, which generates one feature vector and bounding boxes with class tags and probability score. Below is an example of one of the frames from ActivityNet with its class tags and probability scores and its caption. And with the data augmentation techniques, we generated 2 more datasets. One of them comes from back translation, resulting in a size 3 times that of the original. And the second one comes from BERT using random insertion and random substitution, resulting in a size 9 times that of the original. Below are some examples of the augmented sentences. And the results are currently, the best model comes from the pristine dataset by training 30 epochs with cross-validation, followed by 4 epochs of self-critical sequence training. The metric scores are on the right, and we can see that currently the validation score is still very low, but many predictions accurately represent the image. This is probably due to the central frame not always representing the caption. So one of the alternatives for future work is to select more frames per caption and also to exploit the classes available in ActivityNet in the pipeline. On the far right, you can see an image of ActivityNet using this approach with its annotation and a highly accurate prediction. Thank you.